All right. So hi, everybody, and thank you for joining me to my talk. And thanks, Confidence, for inviting me to speak here. At this talk, I will present my follow-up research on Ruckus Wireless. Ruckus is a wireless solution company owned by CommScope. And I first noticed them when they partnered with BlackHat for their Wi-Fi conference solution. And in the last year, I've been doing vulnerability research on Ruckus devices. And so far, I managed to find several of critical vulnerabilities. So this is my a screenshot from my previous research that was introduced in CCC. And back then in 19, before the coronavirus, going to places was a thing. So here you can see me actually talking at a real conference, which is exciting. Although online is good as well. Okay, so I'll just would like to introduce myself really quickly. So my name is Zror. I'm a research team leader at Aleph Research by HCL AppScan. And I've been doing vulnerability research for some time. I like to focus on embedded devices research in particular. And I would also like to do a quick recap for my previous research. So in that research, I demonstrated 3 different ways to execute code on Ruckus devices. All the vulnerabilities were found on the device web interface. The first RCE was credential leakage with SSH jailbreak. The second was unauthenticated stack buffer overflow. And the third one was command injection that was reachable without authentication by writing a web page. All right, and for this talk, I will be using Ruckus R510 Unleashed. The Unleashed version are access points that don't rely on a specific Wi-Fi controller. And moreover, all access points in that list share the same vulnerable code base. And besides of that, I also noticed that some vulnerabilities works on the ZoneDirector product line, which is the Wi-Fi controllers for the access points. Okay, so what's new with this research? So this research began right after I downloaded Ruckus Fix for my previous research. I noticed that they did not fix one of my vulnerabilities correctly. And I then decided to try to re-enable it. And besides of that, my first research was done entirely based on device emulation. Now I own an actual device, and I can try to understand if I got something wrong with the emulation or something like that. Okay. Oops, sorry, I forgot the last bullet. And so before I get into the vulnerabilities itself, I would like to introduce a really cool Ghidra script that really helped me with this specific research. So I'd first like to introduce my previous script. So in my previous research, I wrote a Ghidra script that fetches function name from log strings that Ruckus left in their binaries. Here you can see that they provide a lot of information in their logging. And this script helped me rename function by parsing these long lines that contains the function name. As you can see here on line 38, there's the long number, and I can fetch the function name from it. We also got a generic version already for that script, so feel free to check our GitHub for this script. And the thing is that this script really helped me with most of the Ruckus binaries. But there were some binaries that were not written by Ruckus. So, well, it's a common thing in embedded devices vendor to use open source project in their devices. Ruckus decided to base their web server on a popular project called Embed This. So they extended its functionality by adding some code to it. And since Embed This sources are public, I don't really need to reverse the entire web server binary, and it was just easier for me to review the code itself. But the problem is, what about the parts that Ruckus added? I would like to be able to mark them and see them on Ghidra, so I'll know I'll have to actually reverse them. So for that, I wrote an additional Ghidra script. In my new script, I try to extract as many function names as I can from the Embed This source code. Luckily, I discovered a debug function that contains the exact C file name and line number in the Embed This sources. Here we can see that for this unnamed function from the web server binary, we get that this function appears in server.c file around the line number 138. So if we go to this line number at the Embed This sources, we'll be able to extract many function names from it. And so this is the function in Ghidra after the conversation. And these are actually all the function name that I was able to extract from the source code into Ghidra. And let's have another example. Let's take a look at this function, call graph. This function called ma-create web server. It's being called from main, and as you can see, it calls other function. So on the right side, we can see all the function name I was able to fetch from the sources by using the script I just introduced. And on the bottom left side, you can see the function name I was able to fetch by using the script from my previous research, because Ruckus still used their logging convention that contains function names. And as you can see, there are still unnamed function, but still the majority of function here are now named. And this is a very good example of how these two functions help me get plenty of information and save me a lot of time on reversing. So, well, now I work on writing a generic version for that script that won't rely on a specific debug information. And once it's done, I'll share it in our Aleph GitHub account. So meanwhile, feel free to check it and check other tools we got in this GitLab as well. Okay, cool. So now we're ready for this, for some exploit. And this is my first RCE. In this attack, I found another stack buffer overflow that was reachable without authentication with a web request. And now we're going to go for an online live demo. And there are so many things that can go wrong. So please, demo god, spare me on this one. Okay, so let me just open my terminals. I will use two. And first, I would like to show you guys the Stack Overflow payload itself. Let me just use BI for that. Okay, so as you can see here, this is the payload, and okay, so this is the payload, and we're going to use a netcat that's going to create a reverse shell to my machine. This is why I'm using two terminals. So in my second terminal, I'm just going to listen to port 1337, of course. Okay, now I'm listening, and all I have to do is just use wget to send the payload. So here we can see I'm just using a standard wget that's gonna send this payload to this specific page on, this is my router. This is my router IP address, and that's it. Wish me luck. Oh yeah, things happened. Let's see if ls works. Awesome. So this is a remote shell, and I can check that I am what's my user. So I'm the admin, and admin user is part of the root group, which means I totally own this device. Awesome, and it went well as well. Okay. So before I get into this specific vulnerability, here's a quick recap for my previous talk, just to create the right context. So there are 3 important binaries in the web interface. The first one is /bin/webs. This is the actual embed this web server, and it handles HTTP requests and executes handlers according to its configuration. And it then sends command through a Unix domain socket to emfd. /bin/emfd is an executable that contains the web interface logic. It maps function from web pages to their own function. And it's then implement web interface commands such as backup, network configuration, retrieve of system information, and much more. The last one is the library libenf. This library is used by emfd for mainly for web authentication, input validation, and sometimes even code execution. Just one more thing. Please note that in my previous research, most of the vulnerabilities were related to emfd. However, now the Stack Overflow I'm about to demonstrate or about to talk about is in the web interface, in the web server. And now let's look at this in a diagram. So first, webs listen to HTTP/HTTPS. If it receives a JSA page request, it uses EGS handler to pass a function name to emfd. emfd then checks if the function name is map, and if so, it calls the right function pointer. Eventually, emfd runs some kind of shell command, for example, ifconfig, IP tables, routes, and things like that. Okay, and since the web server contained embed this code and Ruckus code, I decided to mark Ruckus function with RKS prefix. Ruckus has added a new function that registers new EGS functionality. EGS is a handler that runs if the web server receives JSP page request. So here we can see there are 12 functions that were registered. Each function registration needs a function name and a function pointer. Now let's understand how we can reach these functions with an HTTP request. So for example, when sending an HTTP request to /admin/webpage/Wi-Fi network/wlan sysconfirm.jsp, the web server invokes an EGS handler. And on this page, we can see that EGS script has this special tag, and EGS functions are being called from it. Webs maps every strings it received to a function pointer and then runs it. Here we can see that a function called escapejstr is being called. And here we can see another function named s, which is also being called. And yeah, they actually named a function s. I'm serious. And yes, this is by far the worst naming convention I ever see. But well, naming convention, it's not the only lousy thing about these functions. When I reviewed these functions, I noticed that s, str, escape.js, and getCookieValue are all using unsafe string copy. Whoops. Oh yeah, that's okay. That means if I can find a web page that passes the user input to one of these functions, I will be able to smash the web server stack. So to search for an input that leads to one of these functions, I decided to use just grep. I search if there's any calls to one of these functions with a non-static value. It also should not be a session-related or session-evaluated value, because I might not be able to create this, this session or manipulate this session. So this is the regex that makes sure S doesn't get any value inside a double or a single quote, aka static content. I managed to find two JSP pages. One was an error page, which did not receive any user input, and the other was this wlan sysconfirm.jsp. So let's have a look at this page. Well, we saw that S function receives a non-static value called content. And thankfully, the content variable is set directly by an HTTP body parameter called content key. So all I had to do is just send the right request to wlan sysconfirm.jsp, and this is how I smashed the stack. As for exploitation, so R510 uses both NX and ASLR. To overcome NX, I just decided to use a simple rope gadget. So these two gadgets run a system with a pointer to my payload. And in this case, I was using the netcat to create a reverse shell to my machine. And for ASLR, I just decided to take the brute force approach, and that way I managed to overcome its 9 bits of randomness. Okay, so before I continue with my second attack, I would like to share other vulnerabilities I found that I think worth mentioning. So I found a cross-site scripting, denial of service, and information leakage that might lead to another jailbreak. All of them were found either in the web server or in EMFD. I discovered the cross-site scripting on my first research, and well, it's a pretty straightforward vulnerability. So for every Ajax post request to, let's say, /admin /wla cmd.jsp, we have to send this updater attribute. So this attribute is simply reflected without any validation. So all I had to do is just send the right payload, and for each request we send to cmd.jsp, we can run, in this example, this alert JS. Okay, the other vulnerability was denial of service. So while researching, I actually came across this vulnerability, this request that simply crashes the web server. I must say I found it by mistake, and I did not invest too much time in this specific vulnerability. It seems like a null pointer, and I don't think it can be more than a denial of service. Another thing, I think it may be even related to the web server itself. But again, I did not invest too much time in this specific vulnerability. And the last one is the information leakage. So Ruckus, they consider the device serial number as sensitive information. In my previous research, I came across some functions that in Ruckus CLI that rely on this device serial number to escape to BusyBox, to get to jailbreak. And in this research, I noticed that upnp.jsp page is reachable without authentication. And well, this page gives many useful information on the device. And well, it can be used for fingerprinting. But the best part, it could be used, well, we get the serial number, and we could use it for potentially jailbreak the device again. Awesome. So this is the time for my second RCE. And this attack, I found a way to reuse my command injection vulnerability from previous research. I then had to find a new way to bypass authentication, and I did it by overwriting admin credentials. Okay, so let's first understand how the command injection used to work in my previous research. So EMFD execute code in a really messy way. EMFD sometimes uses libemf, other time calls a shell script called syswrapper.sh, and sometimes it just execute the command itself by using libc. These are all the different functions that EMFD uses to execute shell commands. And as we can see here, there are many libc system functions. So I had to find a page that uses this system function without input validation. And luckily, I found 4 functions that called system and were vulnerable to command injection. And I will be using, for the demonstration, I will be using the cmd import avp port function. Okay, so to reach the vulnerable function, I had to send an Ajax request to /admin/_cmdstat.jsp. This request uses an EMFD command called import avp port. And when EMFD receives its request, it uses another function called cmd import avp port, a function inside EMFD. And this function uses libc system function just unsafely. So let's have a look on the function decompiled code. So for my previous research, for my previous command injection, all I had to do is to pass a command injection in the upload file attribute. And as you can see, it just executed without any input validation. The only problem was that I had to be authenticated to reach this function. As you can see, we must have a valid cookie and a CSRF token and this kind of stuff. Okay, so now that we understand the previous command injection, let's have a look on how Ruckus tried to fix it. So they decided to use a function called isValidateInputString that's supposed to validate there is no injection character in the upload file attribute. And this function, so this is an external util function found in libemfd. And this specific input validation function is being used widely for input validation in the entire system. Okay, so let's have a look at this validation function. Here are all the forbidden characters for a given input. At first, this validation seems pretty solid. However, some very important characters were missing from that list. And something I like to do when reviewing a validator, I try to create a set of all the printable non-alphanumeric characters that can pass this specific validator. And after some trial and error, I realized the Shebang sign, which is a pound key followed by exclamation mark, is a valid input. And I could also use a slash. So I could actually create a shebang /bin/sh. Well, that was good, but not good enough. I couldn't just append this shebang payload to a command and to system command, and it won't just runs it. And this is because shebang has to be in a line of its own. Luckily, I could also use a new line character. Yeah, that's actually true. New line character as a parameter input was not being validated, not in the web server, in EMFD, anywhere. I can just send a new line. And well, the result of shebang plus new line is a match made in exploit heaven. Okay, so that was great news. I can now replace my injection with a shebang, but there's one last thing left to solve. Space characters was, well, the space character was not valid input. So I decided to replace spaces with tabs. So here we can look on the new payload. As you can see, semicolon was replaced by shebang, and spaces were replaced by tabs. And that's it. This is how I was able to re-enable my old command injection. The last thing I had to do to complete this exploit was to bypass authentication again, because Ruckus already fixed all the bypass authentication I found in my first research. Okay, so now I would like to explain how the admin credentials are stored on the device. So there's this system.xml, and this is the device general configuration file. It contains the admin credentials as well as other important configuration. And here we can see that the admin XML element, so we can see the admin XML element itself, and we can also see that its password is being stored in the xPassword attribute. Another thing, while I was working on this specific exploit, I noticed that Ruckus has decided to use the most secure mechanism for storing sensitive password. So if you look at this xPassword attribute, you might think that that my password for this specific device is 2345BCD. However, this is not the case, because the real password is 12345ABC. And yes, Ruckus, for some reason, are obfuscating the password by adding 1 to each character. And well, if you don't get it, neither do I. I got no idea why would they do that, but that's how it is. Yeah. Okay. But enough about that. Now let's have a look at /admin/_WLA_conf.jsp page. We can see that this page calls for two functions in EMFD, without login access check and Ajax conf. Please note that we must first pass the login without access check function to get to the vulnerable Ajax conf function. So without login access check expects an Ajax request XML that contains either setconf or doCMD action. The doCMD action in this case was very limited in its functionality, so I just decided to focus on the setconf action. And so the setconf action uses an EMFD function called check reset credentials conf para. This function expects an admin XML element with these following attributes. And this function only validates there are 8 attributes. and it only checks that the attribute names, not the value. Also, they don't check you got any permission. So that means I only need to keep a certain format, and I can overcome this specific function. OK, so here we can see a valid Ajax request with admin element. So this request has all the right attribute names, and it can reach to the vulnerable Ajax conf function. And now let's talk about Ajax conf. So Ajax conf is a big function that does all sorts of things. One of them is using an adapter called adapter setconf to update different configuration files. And in particular, it can update the main system.xml configuration. As we saw, without login access check forces me to use a specific XML element. But thankfully, this is the admin credentials element. So let's understand how the adapter setconf works. OK, so this is how the adapter setconf function looks like. It receives the request component attribute and the Ajax request itself. I also realized that if the component equals to system, then it can only update a specific XML element, which was not the admin element that I was hoping to actually change. So I can't just override the admin credentials with a simple request. However, if the component attribute is not equal to system, it uses a function called repo get cur child. And this function gets a component name and looks for an XML configuration file with that name. So in other words, I can access any XML file in the rspider directory, which is the configuration directory. Well, I can access every XML file except for system.xml because, as I said before, adapter setconf makes sure it's excluded. But the credentials I want to override is in system.xml, which sucks ass. Yeah, so this is where slash come to our rescue. I noticed that if I add a slash at the beginning of the component attribute, it's no longer a system component. It's now a slash system component. And this way, I was able to pass the system attribute check. And now repo get cur child function will look for the file /system.xml, which is totally fine since in POSIX we can add as many slashes as we want and we'll still get the right file. OK, and so this is it. Adapter setconf has replaced the admin credentials in system.xml, which means I was able to override admin credentials. Now I just need to chain these two vulnerabilities together. So first, the overwrite. Then command injection to pop a shell on the device. And well, since I try to be a polite person, after getting a shell, I can obtain the original credentials by grepping /var/run/rpm key. And by the way, this specific file was the one I leaked in my first research to get authentication bypass. So yeah, fortunately, as we saw before, Ruckus insists on saving passwords as plain text. So thank you for that. OK, so all I have to do is to repeat the attack with the original credentials. And this is how we can also avoid leaving any footprint on the device. OK, so this is the time for my final and second demo. For this, I'll only use a single screen terminal. And okay, first I would like to show you guys the override itself. Let's open it with VI. Okay, so as we saw before, this is the admin element, XML element, and this is the password. We can just use a different password. Let's go with confidence 2020. And okay, so this is it. Another payload I would like to share with you is the new command injection. And here, as we saw, there's the upload file. And here I'm using the Shebang with a new line. And I'm running a telnet with tabs that's going to listen to port 7331. What, of course. OK. So let's start with the credentials override. Yeah, OK. So again, this is a standard wget request with the payload to admin WLA conf. And this is it. The credentials were override. Now I would like to do a standard login request. So here, yeah, I already got it saved, but here is the new credentials, right? Admin and confidence 2020. And as we can see, I got a cookie and I got a CSRF. Now I would like to run my command injection. So this is it. And I just need to update the right cookie and we'll be good to go. So this is the cookie. And let's, why not? Let's update the CSRF token as well. Okay, so this is it. Now we're going to send the payload that's going to run a telnet on the device. Okay, seems okay. All I need to do now is to telnet my device on 722.331. And yeah, as you can see, I got a BusyBox shell. I'm the root, and of course, I'm part of the root group. And yeah, this is it. So this is the other way we managed to hack the access point. Okay, so in conclusion, today I demonstrated two pre-auth RCE. The first one was pre-auth stack buffer overflow, and the second was command injection with credentials override. I will also share my new and improved Ghidra script that really helped me with this specific research. Ruckus Networks was informed about these vulnerabilities. I requested 6 CVEs and they confirmed them all. And in total, in these two research were concluded in 17 CVEs that resulted in 5 different RCEs. So as I usually say in my talk, if there are any Ruckus users here, you should stop what you're doing and check that you're running the latest firmware. If not, then tough luck. Okay, so well, this is it. These two research were tons of fun. I'm really glad that I helped Ruckus making their equipment better. By the end of this week, I will post my second blog post at alephtsecurity.com. Feel free to check our blog for my previous research, for this research, and other amazing research done by our group. And this is it. Thank you very much for listening, and stay safe and healthy. I think this is the time I pass the microphone.